All right, welcome back, guys. In this part 2 video of 2.5 lesson, we're gonna go over this last example here. Sort of like an application, a math application of derivative, and kind of tied with everything we've done in the review regarding linear, how to find equation. In this case, we're gonna learn how to find equation of tangent line to the graph is so important. So what we're given here is a function as the fourth degree function. We don't know what that looked like. We can graph that afterwards. But the first thing we have to do is find the derivative function of this. Okay, so that is find f prime of x. So what this means is we're just gonna apply the power rule and get the answer. Okay, so it turns out we can differentiate term by term. There is a rule for that. We can differentiate x to the 4 and then subtract the derivative of 6x squared and then plus the derivative of 10 and still get the same answer. So this is saying that the derivative of sum is the sum of the derivative, and that's one of the rules that we can use here. So anyway, let's go through this. The derivative of x to the 4th using the power rule is 4x to the 3rd. And then the derivative of 6x squared is going to be 12x, because 2 minus 1 is going to be 1 for the power. And then the derivative of 10 is going to be 0. So that's using the constant rule right there, constant rule. Okay, so we have 4x to the 3rd minus 12x is our answer there. Okay, so we can just erase that. So that's part A. So with this function here, with this derivative function, it allows us to tell how this f of x is behaving at any part of the graph, any position on the graph that we want to look at. Okay, so that's what the derivative is asking, is telling us to do. Okay, so now we want to find the equation of the tangent line at x equal to 1. So what this asking is that, hey, whatever the graph look like, I want to find, suppose the graph look like this here. I'm just going to randomly draw this graph. I don't know what this graph look like. Okay, suppose this graph look like that. And it's just asking, okay, well, at x equal to 1, here's 1. Let's say here's 1. Find the equation that tangent to the graph at x equal to 1. So maybe find this tangent here. Find that y equal to mx plus b. Find that equation. Okay, remember the graph may not look like that. I just drew that randomly. So that's what we're going to do, okay? So the equation of tangent line at x equal 1 to this graph, we can start by write that equation in the format of slope-intercept form. So we said tangent equation. Okay, so y equal to mx plus b, okay? And the slope of the tangent equation, so the m is a slope, is equal to the derivative of the function at that point when x equal to 1, okay? So that's the first thing we do is find the slope, which is equal to f prime of x. So let's go ahead and do that. F prime of x is going to be 4 times 1 to the 3rd minus 12 times 1. So we're looking at 4 minus 12, which is negative 8. So the tangent slope, we'll call that tangent slope, which is m, is equal to negative 8. So now we're just going to find the y-intercept, and then we're done, okay? To find the y-intercept, okay, to find b, we need a point on that line. Well, a point on that line is the same point on the graph f of x because it's tangent to the graph. So we need a point. So a point on the line is x equal to 1, and then y is f of 1. That's how we find the coordinate for y. So f of 1 is going to be 1 to the 4th minus 6 times 1 squared plus 10. We plug 1 into the function f of x. So that gives us 1 minus 6 plus 10. So that is 5. Okay. Or it's not. Yeah, it's 5. Okay, it's 5. So the point is 1 comma 5. So this is called the tangent point. So this is the tangent point. Okay, so we need two things to find tangent equation. We need tangent point, and then we need tangent slope. Okay, so now we're ready to find the tangent equation. All right. So we said, all right, I'm gonna plug these information into my slope-intercept form. My y is 5, my m is -8, my x is 1. I'm gonna solve for b. So therefore b in this case is 13. So my tangent equation, okay, it's gonna be y equals -8x plus 13. Okay. All right. So I'm gonna show you guys that right now through Desmo what that looked like visually. Okay, so I'm gonna go ahead and graph this x to the 4 minus 6x squared plus 10. So let's go Desmo. Where's my Desmo at? Where is the Desmo? There it is. Okay. So I'm gonna say, all right. So y equals x to the 4th x to the 4th minus 6x squared plus 10. Okay, so that's gonna be my graph. And then I'm gonna go ahead and plot the tangent line as well. So the tangent line we found was y equals minus 8x plus 13. Okay, so now we ready to zoom in. Okay, so what we just found there is, here's the graph of x in red, and then when x is 1, here's x1 when x is 1. Okay, the point on the graph is 5. So at that point, the line that tangent to the graph is the one in blue, and that's what we found. Okay, so this blue line is a tangent line to the graph at the position 1, 5 for the coordinates. Okay, so that's what we found. All right, so that's part B. Part C is asking, hey, find the value of x where the tangent line is horizontal. So what this asking is, where is on the graph, at what x coordinate position, point out to where we potentially have the tangent line touches the graph that is horizontal. Okay, so if I'm going to go back to the graph, okay, I'm going to go ahead and erase this here. We don't need this anymore. So this is saying that, hey, where on the graph that we can draw a tangent horizontal line. Okay, so I'm going to go ahead and just screenshot this real quick, and then I'm going to share that to my note, notability, and then yes, import. Okay, and then go back down to notability. Okay, so part C is saying this here. Okay, part C said, all right, so I'm just gonna go ahead and write part C over here. Part C asking, okay, okay, so find x where the tangent line is horizontal. Okay, so if you look at the graph, I can draw a couple tangent line that's horizontal. So here's one horizontal tangent line, here's another one, and here's another one. All right, the middle one's kind of easy because the middle one, that's when x equal to 0, right? So this is when we got 0. And then here, maybe that's, I don't know, maybe it's 2. And this is what, -1.5. I'm just guessing here. So based on the graph, it's kind of hard. It's kind of hard to do that. I mean, if we go back to the actual graph, we can find that really. Actual graph, that point there is -1.732. This point there, the x is 0. This point here is 1.732. But what if we don't have the graph? How do we find those x values? How do we find those x values without relying to the graph? Okay. So this is what we're gonna do. Okay. To find the horizontal, find the x value that makes the horizontal tangent line, we do this. Okay. So C. Okay. To find x such that tangent line is horizontal. Okay, so we say that tangent line horizontal, so tangent, so we say, let's do horizontal tangent line as slope of 0. Why? Because horizontal line have slope of 0. And slope of 0, slope is 0 is just mean where x such that, or what xy such that, so say what xy such that the slope is 0, right? Slope is f prime of x. So that's where we're going to start. We're going to say solve this here. F prime of x equals 0. Well, we already found f prime of x. That function was 4x to the third minus 12x. So we said 4x to the third minus 12x equals 0. And we're going to solve for the x values. So we can solve for the x value by factor out a 4x. So that gave us x squared minus 3 there. Okay. Using 0 factor property, we can say that 4x equal to 0 or x squared minus 3 equals 0. So one answer from here is x equals 0. That's what we saw on the graph. And the other answer here is plus or minus root 3. Oh, it's actually two answers. So the solutions is 0, root 3, and negative root 3. And that's what we determine on the graph. Negative root 3 is 1.732. Okay, so that's how you find the value of x where the tangent line is horizontal. Okay.